Good morning. We're going to talk about a couple of things in this video. The first thing we're going to talk about is the rate of change. And if you remember, the rate of change is an average rate of change. So it's the difference in the slope or how 2 points are changing. So it's over some interval. And we've got a couple of formulas. Our slope formula that we should all be familiar with is just rise over run, which is the change in y divided by the change in x. And we can write that as y2 minus y1 divided by x2 minus x1. And so the definition, the rate of change is the slope of the secant line between 2 points. The next thing, we'll do some examples of this and kind of see how the rate of change and the derivative relate to each other. So the derivative is the instantaneous rate of change. So where the rate of change or the average rate of change is the rate of change between two separate points, the derivative is the rate of change exactly at 1 point. And so the limit definition is f prime of x, this means this is our derivative, is the limit as h approaches 0 of f of x plus h minus x f of x over h. And then want to just remember our power rule. If f of x is equal to a times x to the n, then the derivative f prime of x is equal to an times x to the n minus 1. Okay. So if I'm looking at my function, f of x is equal to x cubed plus 4x squared minus 5, and I'm just wanting to find the rate of change, right? So I want to find the rate of change between 2 points. I could pick 2 points. I could pick the point -2, 3 and the point 0, -5, and I could find the average rate of change over this entire distance, right? And so if I was to do that, this is easy. We've got points. It's just m equals y2 minus y1 over x2 minus x1. And so I would just plug our values in. It might be helpful to label them. And we end up with, we'll say -5. So -5 minus 3 divided by 0 minus -2. And of course, that's -8 over 2, which is -4. So on this interval, from this point to this point, it's changing. The average rate of change is -4. Now what happens is, if say I wanted to know the rate of change at this point, right? At this point right here at -1, -2, well, we could move these points in and keep doing this average rate of change, but it's always going to be over some interval, right? So when we take our derivative, what we're doing is we're moving these points in until the distance between the 2 points approaches 0. And so we're getting really, really, really close to this point, and essentially the distance becomes 0. And so what we need to do is we need to take our function. F of x is x cubed plus 4x squared minus 5. And the first thing that we need to do, if we want to find the instantaneous rate of change at that point at -1, -2, is we need to find the derivative of this function. And I'm just going to use the power rule. So we know that f prime of x is, our 3 comes down, so it's 3x, and it's n minus, so x to the n minus 1. This becomes 3 minus 1 is 2, plus my 2 comes down, 8x. And then the derivative of a constant is, of course, 0. And so this is the rate of change of this function. If we want to know what the rate of change is at this point, we need to plug this x value in and evaluate it. So the x value of this point is -1. So it's f prime of -1 is equal to 3 times -1 squared plus 8 times -1. And so -1 squared is 1. And 3 times 1 is 3. And 8 times -1 is -8. 3 minus 8 is -5. So f prime of -1 is 5. So what that means is at this point, the rate of change is -5, -5 over 1. Over this larger interval, the rate of change was -4. But as this interval gets smaller and smaller and smaller, this interval that we're taking the rate of change of, that average rate of change becomes more and more accurate. And taking the derivative and evaluating it at that point gives us the most accurate rate of change, or the instantaneous range, exactly at this point. And then hopefully this helped you and answered some questions.